Climate change, a problem that lingers in the back of everyone's mind, one that seems inescapable and leaves a feeling of helplessness. Everyone knows what to do, but not how to do it. In recent years, there has been much discussion on reducing greenhouse gas emissions, but not enough action. Canada has declared its commitment to emissions reduction, specifically at the recent Paris Climate Accord of 2015. To this end, the Accord has swiftly promoted the reduction of greenhouse gas emissions with the ultimate goal of net zero emission. The road to reducing emissions is cloudy, but there is a tangible solution. Renewable energy is the future, and power to gas is the avenue. But what is power to gas? Power to gas is a flexible form of green energy storage. It converts electricity to a gas fuel, easily stored and ready to be used in a variety of fashions.
We have designed a power-to-gas system for an automotive manufacturing facility in Ontario, reducing their greenhouse gas emissions by 2,400 tons annually. The way it works is simple. At the heart of our power-to-gas system is a core of electrolyzers. They use electrical energy to power a process known as hydrolysis. Hydrolysis uses electrical energy to separate regular tap water into hydrogen and oxygen. To power this process, energy is drawn from the facility's electrical substation, as well as from solar panels that span the manufacturing facility. Gases are then compressed and stored in nearby pressurized tanks for future end market uses.
On site, the hydrogen can be used to distribute sustainable energy to fuel cell forklifts, vehicles, and can also be used to increase the renewable content of natural gas. This hydrogen-enriched stream is fed to a combined heat and power system that provides clean, efficient heat and energy to industrial processes. The emissions cap of the company will fall as a result of these initiatives, and these revenue streams, when combined, can produce profitable and reliable business cases that can be implemented today. Along with power to gas being heavily incentivized by the Government of Ontario, it also allows for cheaper energy to be purchased. A company can simply buy electricity from the grid during off-peak hours, convert it to hydrogen, and use it during on-peak hours to offset the expensive cost of on-peak electricity from the grid.
In an effort to fight climate change, the Government of Ontario has implemented a new system. The cap-and-trade system works off the basis of if a business pollutes less, they pay less. This translates to power to gas, allowing companies to sell off the remaining emissions quota for profit. In other words, an added bonus for being green. Our optimization model combines multiple revenue streams, creating an ideal scenario that maximizes profit while meeting all environmental constraints. This includes revenue earned from the cap-and-trade initiative, selling the oxygen byproduct, and reducing harmful greenhouse gas emissions. The economic analysis suggests a project payback within 3 years, as desired by the automotive manufacturer for initiatives of this scale. The payback period was found to be 2.8 years. The installation of the power-to-gas system will require a total capital investment of roughly $2.6 million. The electrolyzer and 1,500 solar panels will account for 41% and 17% of the capital costs respectively, as they are the major processes used to supply electricity and hydrogen gas, and the compressors will account for most of the operating costs. Based on the sensitivity analysis, the annual revenue for selling hydrogen at $1.5 to $12 can equal between $54,000 and $438,000. To close, versatility, reliability, and sustainability are what makes power to gas the future of clean technologies.